These are notes for section 7.5, solving quadratics by factoring, and these quadratics are trinomials. Before we talk about solving, a quick review of the factoring that we have gone over in the previous two videos. It really keys off of what does the polynomial end with. If it ends in the trinomial, if it ends in a plus c, I'm looking for numbers that multiply to c and add to b, as it says here. If it ends in a minus c at the end of the polynomial, or trinomial rather, I'm looking for numbers that multiply to c and subtract to b. So the numbers game either have to add to the middle or subtract to the middle. So on number 1, I have a trinomial. I know that I can put x and x in the first spot. That will make x squared. And I'm looking for numbers that multiply to 18. 1 times 18, 2 times 9, 3 times 6. Now, which combination will subtract to be 7? And it's subtract because it's a minus sign. Well, that would be 2 times 9. 2 times 9 would subtract to 7. So 2 and 9. The bigger number carries the sign in the middle. The signs have to be opposite in order for those to subtract. On number 2, x and x will make x squared. I'm looking for numbers that multiply to 40. That's 1 times 40, 2 times 20, nope, not 3. Let's go 4 times 10, and 5 times 8. Now, I'm not looking for these numbers to subtract because it ends in a plus sign. Which of those will add to 13? That'd be 5 and 8. Minus 5 minus 8. Now you might say, wait a minute. I thought the signs had to be opposite. Well, that's if they're going to subtract. Signs that are opposite will make numbers subtract. Signs that are the same will make the numbers add. And that's like I don't know what grade that is. Same sign, add and keep, different sign, subtract. On number 3, x and x will get me x squared. I'm looking for numbers that multiply to 20 and add to 9. So numbers that multiply to 20. 1 times 20, 2 times 10, 4 times 5. 4 times 5 would multiply to 20 and add to 9. And if they're going to add, they must be the same sign. And on the last one here, for the quick review, x times x will get me x squared. I'm looking for numbers that multiply to 48. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. I think I got them all. Which of these numbers multiply to 48 and subtract to 8? Would that be 4 times 12? So plus 4 and minus 12. If they subtract, they have to be different signs. Great. The solving portion. You got to move all the terms to the same side, just like we did with the GCF. We got a factor, just like we reviewed. And then we set up two equations using the zero product property. For example, on number 1, x times x will get me x squared. I'm looking for numbers that multiply to 14 and add to 9. So numbers that multiply to 14. 1 times 14, 2 times 7. Minus 2 minus 7 equals 0, of course. Once I have taken this quadratic equation and split it into its two linear factors, I can set up two separate equations, both of them equal to 0, and solve. The reason, or one of the reasons we factor, is to take a quadratic equation and make it into its two linear factors, because we're really good at solving linear equations. You passed Algebra 1. Now on number 2, I'm not ready to factor yet because not all of my terms are on the same side. So the first thing I need to do is subtract 6 to the other side. I need to squeeze a 5 in there. Why didn't I write the 5? That was silly. Let's write plus 5x. There we go. So the first thing I need to do is get all the terms on the same side. Once they are, I can make my two parentheses, and I'm looking for numbers that multiply to 6. And it's very important, they multiply to 6 and subtract to 5. Well, that'd be 1 and 6. So minus 1 and plus 6. Once I have it factored, I can set up two equations, both of them equal to 0, and solve them both. To get rid of a -1, I could add 1. And to get rid of a +6, I can subtract 6. Sorry, kind of running out of room there. I apologize. Down below on the last two examples, number 3, all the terms are on the same side, so I can make my two parentheses. And I'm looking for numbers that multiply to 9 and add to 6. Numbers that multiply to 9, 1 times 9, 3 times 3, and add to 6. So that'd be +3 plus 3. Now, if both of the parentheses are the exact same, you don't necessarily have to do the same problem twice because you're going to get the same answer. It's just a little redundant, so you would only have to write the answer one time. X equal -3. Again, you could do it over here as well. You're going to get the same answer. You don't need to write it twice. Just once would be fine. And on the last one, number 4, x and x will get me x squared. I'm looking for numbers that multiply to 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. The combination that I'm looking for is whatever multiplies to 24 and subtracts to 2. It'd be 4 and 6. So let's go +4 minus 6. Bigger number carries the sign in the middle. From here, I can use the zero product property. That's setting up two separate equations. To get rid of a +4, subtract. To get rid of a -6, we can add. Hopefully that helps. See you on the next one.